or some kind of software thing. Oh, now I got a happy face. Do those all add up to 40? All right, great job. Super. Hey, double check. We got the word frequency. We labeled this. Everything's together. Got our little squiggle. We left some space there, right? All right, hey. Now letter B. We're going to describe the shape of the distribution. So I'll go over here and do that. Doing a great job with this. Letter B. Let's call that letter A. Letter A was constructing the histogram. Letter B, I need you to describe the shape of the distribution. Okay. Describe the shape of the distribution. What are the three most popular? Well, the first most popular shape you're probably going to see, everyone, I can go over here and organize a little chart. I'll show you where it is in the book. Probably the one you're going to see very, very often is a distribution that goes like this. Goes up in the middle, really high, and then it comes back down on this side. And in that case, you could say that it's bell-shaped. That would be our answer. That's an appropriate description for distributions like that. Bell-shaped distribution. Well, this thing is not bell-shaped, do you agree? This is skewed. And so I want to show you. This, if you had a distribution like this, really high on the left, and then it what? Kind of went down to the right like that. That's called skewed, S-K-E-W-E-D. S-K-E-W-E-D, skewed to the right. If you have a hard time remembering left and right, like I don't know which way to say it's skewed, could you think of this like a dog with a little tail? It's like skewed towards the tail. Okay? So what could you call this? Ta-da, what if it went like this? That was over here.
Skewed to the left.
Skewed to the left. Is that okay with that? So I bet you know how to describe this. I bet you know how to describe this on a test. What would you say for this one? Describe the shape of this distribution. Skewed right. Skewed right. All right, skewed to the right. But it's okay if you just say skewed right. Just know how to spell skewed. S-K-E-W-E-D. It's skewed to the right. That's important in our course. I want you to leave this course and be statistically literate. And what you mean is when things are bell-shaped, or your data is skewed to the left, skewed to the right, and you want to report the center, you're going to know what to do. You go, I'm going to use the mean. I'm going to use the mean words that are coming up in the next section. Hey, I guess, what if it was all flat? Everything was flat, you can use the word uniform. And everyone, if you want to see nice pictures of this, and you got your textbook right now, a lot better than what I have, would you go to the bottom of page 92? I'll put that on. Page 92, the author did a great job. Has 4 nice pictures there. Boom, 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 boom. You see, he wrote some really nice images. Cool? And everyone, if your distribution was anything else, golly, make up your own word. I mean, what if it went like this? I don't see a picture like that, so you could probably come up with something for that. You got some of that, Mia? Something's really high over here. Low in the middle. Something up there, I don't know.
Inward bell, I don't know.
She goes inward bell, I love it. Yeah, inverted bell, I love it. Excellent.
Can you use Riemann curve over here? Riemann sum or something?
What's that?
The Riemann sum, if you want to.
Oh yeah, you could.
Right?
That's what this looks like. Anybody here take calculus? Oh, you just brought up a term from calculus, Riemann sum. That's exactly what that looks like. And you get the curve. Yeah, I like that. Very good. All right, everyone, I'm going to erase this. And we're going to talk about a stem and leaf plot. You ever heard of that? Some have heard of that. I see histograms every day. I'm serious. Just going through the internet. You know, reading my articles, doing my research. I see histograms all the time. I bet you do too. Bar graphs too. I'll be honest with you, I don't see many stem and leaf plots. Alright. So in a stem and leaf plot. A stem and leaf plot. We're going to construct one. So I think I'll just give you some numbers to construct this. Nothing crazy. You know, this time I'm not going to do a table with 40 numbers. Well, let's just say these were the numbers that came up on a test out of 100. There were 10 students. And someone scored a 24. Hey, don't get too upset about that student. They had to shove a lot of snow. So they were ready for that. 24, and then there was a 43, 43, 45. All right. And then there was a 52, a 55. 1, 2, 3, 4, 5, 6, 70. All right. So, ten students. And when they took their test, those are the grades. We're going to construct a stem and leaf plot with these 10 grades, okay? Show of hands, who's seen a stem and leaf plot before? Cool. Now I bet you, everyone, all those hands, everyone who saw them, you probably saw it when it was up on its side. I'm pretty sure of it. When you saw a stem and leaf plot, probably on its side. I want to point out, I'm going to make my stem and leaf plot like the last thing we just saw. A stem and leaf plot is just like a histogram, except it's got more information. What I'm going to do is I'm going to put my vertical line here. And you got stem and leaves. So see this 24? The stem is the 2. Guess what the leaf is? The 4. Now what's the rule with this? The rule is, everyone, the leaf can only have 1 digit in it. That's the rule. Your stem can have like 8 digits in it. So, I mean, this is going to be funny, but everyone, let's say I'm talking about the number 682,943, and I wanted to make a stem leaf plot. Well, then I can use the 68294 as my stem. Guess what the leaf would have to be?
3.
The 3. I know. So anyways, the leaf will be 1 digit. That's the rule. But the stem down here can be more than 1, right? So I'm going to keep going. There's my 24. Now, I look up here. Anything in the 30s? I'm going to put my 3 as my stem. My stem is my 3. Anything in the 30s?
No.
Oh, so do I put anything here? Excellent, but I'm going to keep that 3 there. I'm going to keep that 3 there. It's just, there's nothing in the 30s. My next stem is a what?
4.
4. Now, how many in the 40s?
2.
And we'll go in order from lowest to highest. There's a 3. Is there more than 1 3? Yes. So I got to write it again. And then a what?
5.
Is everyone so far so good with this?
Uh-huh.
Doesn't this look like a histogram? Doesn't it look like a stem and leaf plot is a histogram, just has more information in it, right? It's actually showing you the numbers in there. All right. My next stem is a 5. What's the leaves?
2.
2 and 5. Anything for the 6s?
No.
How about the 7?
2.
The 8? The 9? Now I'm stuck.
No, do 10.
How do I do this, everyone? How do I write that?
10, 0.
I love it. The rule is the leaf has to be what? 1 digit. So you're telling me the stem's going to have to be a 10, and then the leaf is just a 0. There you go. And these are the grades. But those show of hands, a lot of people have seen stem and leaf plots before. When you saw these, a lot of times they were up on the side. I'll talk about that. You go, why? What are they doing that? There's a reason behind that. I'll reference something in the book. If you're curious about me for your test, do you have to construct the stem and leaf plot for me? No. I mean, you're going to construct a histogram, you're going to describe it, but here's the deal. If I provided one for you, would you be able to analyze it and read it? That's what I want you to be able to do. If I gave you a stem and leaf plot, I want you to be able to go in there and go, okay, what's that number right there?
24.
Don't be careful, don't call that 42, that's the number what? 24. That's oh, there's no 30s, right? That means there's nothing there, but that's the number what? 43, 43, 45, 52,
55.
55. There you go. You'll be able to read it. That sound good? Awesome.
So that's the plot completed?
Yeah, that's it. It's all done. We constructed our stem and leaf plot. We even labeled it. We said the grades. Now, have you seen these before? I'm curious. Have you ever seen these before? Never. A lot of times when I do these, see, they're not very popular because they're funny looking. Histograms seem to be a better representation because that's what a lot of people use. But sometimes these are useful for comparative reasons. So if you have your textbook, I want to show you one. Would you get a page? It's in 2.2, just at the top of page 99. And if you don't have your book, and on top of page 99 there is a stem and leaf plot. This gives you a reason, or it provides a picture of why they do these on the side. You go, I don't have my book with me right now. Well, what do they have? And when down the middle, they've got, this is fat in grams in fast food sandwiches. On the right side they got BK, and on the left side they get McDonald's. And they started out with the 0 as the stem and the 1 as the stem. They put the stems in the middle. Like this. And they got numbers like this, 40. So in BK there's something as what? 44 grams of fat. Whoa. I know. So that's what we're saying. So now we know why they like to put these on the side like this rather than like this, with the stem going vertical. Because you can compare. So in just your observation, right away when you observe this, those you have your textbook, which restaurant seems to tend to have more fat in their sandwiches? Burger King. That's what we receive. Now who knows, maybe McDonald's made
I got a
this stem
question.
and leaf plot.
So the
Right?
Burger King is 44 and McDonald's is 24?
Let's see. Burger King, there's a 44, but then the McDonald's, there was a 2 over here, so you have to read that as 42 grams.
Oh, 42, okay.
Does that make sense, everyone?
So
All right, great question. So in this stem, we saw there was a 4 here, 44 grams of fat for the BK sandwich, but 42.
Okay.
So the stem's in the middle.
The stem's in the middle. And why do they do this a lot? Because of comparative reasons. You know, hey, cholesterol levels. I'll put men over here, I'll put women over here, right? You're like, gosh, what's wrong with the men? You know, and you're able to see right away. So that's why they do this.
So you can only compare it to you, right?
That's right. I know, how would we do 3? That's a good one though. I like that.
Can you make it like that?
You sure can. You sure can. Now, I won't make you construct one, but absolutely. Because a lot of students like it that way. They like to get the stem right up the side like that, even if it's solo, right? So what would this look like? I would have put the what? If I wanted to just do this solo, you could put your stem on the left or on the right, which way you prefer, and then put these leaves off to the one side. Great job.
I just want to make sure I'm reading that correctly. So for the 0, it's 7 grams. Or 7
You
grams.
got it.
Okay.
So what would this number be? You're reading it correctly. That's 7
7.
grams of fat. And you hear all these questions about this? So now we kind of know why we don't see these too often, do we? They're not, everyone websites, do you see these? And you know where I see them? I see them in like biology textbooks, things like that. That's where I see them. Hey, great job. Hey, for the last 10 minutes or so, I want to talk about section 3.1, but I'm going to leave this up here. Because you know what section 3.1's on? Measure of central tendency. Ah. Well, we can get started with that. Measure of central tendency. We can get started with it. Measure the center. Measure of central tendency. Well, can I just get it started? Sure. We're talking about measuring the middle. So I'm going to start out with this word. There's a word I want to use in statistics. It's called the mean. We're talking about the average. So let's say I wanted to find the average score in this test. Raise your hand, explain to everyone what you would do. Because people know. I'll go to Randy. How would you find the average or the mean?
Add them all together and divide by the number of,
Occurrence.
I love it. You nailed it. That one's like, if he says first you'd have to add all these up. So you know what symbol I'm going to put down? I'm going to go like that. Because that means what? Sigma. All right, I'm going to add up all the scores. Now if you want me to put scores, I guess I can call them x's. Add up all the x's. But when we're up to the statistics, you know, if you remember back in that, this is an algebra class, but I can't call that x and call that x because they're different numbers, right? See what you do in stats? We call this x sub 1. We call that x sub 2. Don't get so worried about the notation, but then we call that x sub 3, right? So what I'm going to do is I'm going to say, how about we add up all the x sub i's? This is the little formula, right? So I'll add up all the x sub i's. And then you said you have to divide by something, right? The number of what? Scores, the number of students, the number of elements. Do you remember last class I had a letter that represented the size of a sample?
N.
It was a little n. Do you remember that? So I'm going to put over lowercase n. As if this was the size of my sample. And you all know how many students were there. There were 10, right? But that's what we're going to add all these up and divide by 10, true? And I'll wait for a couple students to do that. We'll get someone to verify it. Take your time. So we're going to get the mean. And let's say this was just a sample of students. I'm going to call it the sample mean, okay? That's the formula. It's provided on your formula sheet. I just don't think anybody's going to have to look at that on a test. Do you agree? Or I just don't think you're going to have to go, let me go look up the formula for finding the sample mean. You're going to know, I got to add all these up, divide by the number, right? Yeah. But it'll be on it.
61 is the average.
You got 61. Anybody else get 61? I'm surprised it didn't have anything like 61.2 in there, huh? So it's just a 61? Awesome. Now, and what's the symbol for this? We got to get used to this notation. X with the bar over it. And we call it X bar. So X bar is the symbol for the sample mean. Call it X bar. It's an X with a what? A flat bar over it. So when you hear the term X bar, you're like, someone's talking about the sample mean. That means the average. Kind of what's going on in the middle. All right, I'm going to put a line. Great job of finding a sample mean.